to Complexity Made Simple. My name is Paul Allen, and in this video newsletter what we're going to talk about is how to select the right problem solving method. And really what this is all about is whether it's about tools, whether it's about process, or whether it's about principles. So let's have a look. How to select the right problem solving. Okay, now this was triggered by something that appeared on LinkedIn. Somebody posted a flow diagram. To be honest, these flow diagrams are something that I like to use. Maybe I'll share my flow diagram with you in a moment. But I opened this flow diagram, had a look at it and thought, that's absolutely useless. And not only does this go to the how to select the right problem solving technique, this goes to the heart of how do you select the right training providers for the quality tools and Six Sigma and those types of activities. Because some trainers are just going to teach you the tools and then they're going to keep it really dry, whereas some people are going to teach you how to use the tools, and that is at the heart of the secret of getting the right knowledge and getting the right training providers. So okay, first of all, let's take a look at the little flow diagram that's triggered this video. So here it is. Now you can see here on the diagram it says how to select the right problem solving method, and it goes problems identified. Is the problem part of a well-managed process? Yes or no? Now that is something that I would recommend. I ask that question. I have to say the language that I use is the process in control or is the process in chaos? Okay, so that's the way I ask that question, and I'm quite happy with that question. Okay, so having asked whether the process is in control or whether the process is in chaos, the next box says, okay, the process is in chaos, and it says, implement ISO 9001. What? What? What kind of a suggestion is that? What this is all about, you've got to understand your process physics. Okay, so problem solving is all about process physics. You've got to understand the nature of your process physics, and then you've got to understand how to change that in order to get the result that you want. Okay, so is your problem part of a well-managed process? Now the problem with asking that question is that everybody's going to say yes. All right, so that's the first thing. Everybody's going to say yes to that. What manager is going to say, no, my area is a complete rip-roaring disaster? All right, so is it part of a well-managed process? Now I say, is it in chaos or is it in control? And then I give an example about what the process physics looks like in order to make the decision. Are you in chaos? The process just randomly, plot a graph, by the way, there's the important thing. Never look at numbers, always look at pictures. Plot a run chart. Look at the run chart. Does that look like a process in control to you? Does that look like a process which is well managed? What am I trying to do? Trying to understand the process physics. So what have I got? Is it that? Does that look like a well-managed process? Then something unique's happened. Yeah, so this diagram, we're asking the question, is it part of a well-managed process? But you've got to say, nobody's going to say no to that. Everybody's going to say, yeah, of course, my area's well managed. Nobody's going to own up to a badly managed process. But what's the process physics? Are we in control or are we in chaos? And then you can start to use techniques and you can apply solutions that get the process under control. Now, don't get me wrong. Is ISO 9000 a technique for helping you to control a process? You know, if I wanted to achieve this, would ISO 9001 be part of my solution? Yeah, of course it would. If I got this though, if I got a problem like this and we went to a specific machine now, this would be a specific machine. I've got a specific piece of machinery that's upsetting the customer, causing us loads of cost, and somebody says, is it part of a well-managed process? Clearly the answer, process physics. Now, this is a process in chaos. This is a process in control. To solve this, I'm going to implement ISO 9001. I would say that could take you over a year. And I would also say, if you don't understand the physics, it won't even work. Most ISO 9001 implementations do not do this. They do not do this because people do not understand the process physics. If you've got a process that looks like this, you have inputs, and I'm only going to put 4 or 5 on my diagram. You've got outputs. Your outputs are all over the place, therefore the result is chaos. What don't you have? You don't have process controls here. You don't have, and by the way, what a process control means is you fix your inputs. That's the physics that I'm going to transform. If I want to transform that physics and achieve this, if I want to go from there to there, the process physics says control the inputs to that machine. Control the inputs to that process. And by the way, we could be in an office process that looks as disastrous as this. It doesn't have to be a piece of machinery. Every process responds to this process physics. You put variability in other words, you let these move around, you'll get this chaotic response out the other end. Think of these like a handful of dice. You're rolling dice every day. The dice land on different numbers. What do you get? Well, you get some random chaotic number out the other end. That's what you're allowing. If you fix these, physics says you have to have this. You have to create a consistent result. Then when you create a consistent result, if you don't quite like the where it's landing, this is relatively easy to do. Okay, so process physics, ISO 9000 definitely isn't the solution. Man alive. Let's take a look at the rest of the diagram. Okay, is the solution known? Now, what a weird question that is. You don't know the problem at this point. So if you go, are you in chaos or are you in control? Surely what you've got to do is diagnose the problem first. Then you can think about, do you know what the solution is? What else does it say? Are any special causes present? Well, what does that mean? You know, we're talking in language that people don't understand. When what we want to talk in is a language that people understand. You know, when you look at pictures, I don't need to talk about special causes and common causes. I know that's a very statistical process control phrase. What sort of problem have we got? Have we got this or have we got this? Now this is known as common cause variability. This is known as special cause variability. Special cause variability, by the way, is usually one root cause. This thing up here, multi-causal. This thing will take a team 3 months to fix. This thing should take one person about 3 minutes to fix. Okay, so you can see these are very different techniques, but I need to understand the physics. I need to look at the graph, understand the physics, and then understand what I'm trying to transform. To draw these pictures in a slightly different way, does your problem look like this, where you're trying to reduce the chaotic variability? So you're trying to go from there to there, or does your problem look like this? Is it off center? Now these are just easy to understand common sense principles of your process physics. That's what you need in all of your training. That's what you need to understand. Now look, I just drew some simple diagrams here. Simple diagram, which state am I in? Use a team, 3 months to fix all the inputs. Simple diagram, use one person. What will they do? They'll do a process audit of all the rules. And they'll find one root cause, and then they can decide why that rule was broken. What was the problem? Is there something missing? And then we can apply a fix to it. But to ask the question, is the solution known? Right in that first box, you need to understand simple process physics. What am I trying to do? Am I trying to reduce the variability? Am I trying to move the thing back on target like this? Is it going to take me 3 months? Is it going to take me 3 minutes? Do I need a team? Do I need one person? Now all of this simple explanation is missing from most training. The Six Sigma training that you get, all of this simple explanation is just missing. People just want to teach you SPC as a tool, FMEA as a tool. They want to teach you cause and effect analysis as a tool. They want to teach you histograms and CPK analysis. But at no point do they teach you process physics. This diagram that we're looking at here, at no point does he talk about process physics. It's of no practical use to you whatsoever. Now here is my diagram. If you want this diagram, please send me an email and I'm happy to furnish you with this diagram. But you can see I'm asking the question, is it in chaos or is it in control? And then I take you through a series of steps in order for you to diagnose what's going on. But where do we end up? In every case, we end up here. We end up with the control systems that are in your business. Every solution that you're going to select is going to be about the control systems you already have. You might already have this. That could be one of the techniques you use to get a better result. You've got 5S in your business. This is a control technique. It's a control system you're already using. You're already using TPM or planned maintenance techniques. Maybe we're going to use that as a solution. You're already using standard operating procedures. Maybe we're going to use that as a solution. And often lots of machines have already got mistake proofing devices, things like alarms. We have settings which are under a password so that we mistake proof out. All of your solutions will be about your control systems. You already have the answer to every problem you have in the company. You're already paying for all of these systems to run. What you haven't done, if you've got a problem, you haven't quite attached them properly to this end of the process. So there's some kind of disconnect, and you haven't quite attached them to your money making process. So that's always going to be the answer. This is always going to be the answer. The only question is, what went wrong? One thing or multiple things? And that's all based on process physics. Learn the process physics. Learn how to use all of your control systems that you're already paying for. Guess what you're going to do? You're going to be super successful and you're going to make more money.